Hello, my dudes. We're going to very soon get into a good bit of lab work with our study of circuitry. So in order to do that, we're going to have to use some devices to measure some important quantities. And we will use what are called ammeters and voltmeters. Actually, what we'll use are called multimeters. This is a picture of the kind of multimeter that we use. Not great resolution, but you'll recognize this thing hopefully when you see it next time I see you. If we zoom in on this area of it, it looks sort of like that. That's a different model over there on your left, but it has some common features. All right, and so we got to talk about what stuff is for. All right, first of all, important to talk about what each of these is for. An ammeter measures current. People want to say measures amps. That's sort of like saying measures seconds, right? We actually say, well, we want to measure time. We don't really typically talk about the units of the thing we want to measure. We talk about the quantity itself. So ammeters are devices used to measure current. All right, voltmeters, a little more straightforward. They're used, to measure voltage. Now, the nice thing about a multimeter, which is what we'll use, is that you can, depending on how you set them up, you can configure them to measure current as an ammeter or to measure voltage as a voltmeter. All right, and that configuration depends on where you turn this knob, where you point that indicator, and what terminals you use, what two of those three terminals you use to plug what we call leads into. All right. And so, well, item one lead, and a lead is a wire. One lead always goes in the common terminal. No matter what, we always plug one lead into the COM, common terminal. Okay, now where the other lead goes depends on what you want to measure. Now notice, over here, 10A DC, that's a measure of current. So if we want to measure currents, we plug the other lead into there. Notice over here, we've got volts, ohms, well, and milliamps. So we can actually measure current if we plug the other lead in over here as well, except here's the deal. Most of our, what do you call them, multimeters are not going to work great if you try to use this terminal to measure current, and that's because of the nature of the nature of ammeters. They're very sensitive, and when people screw them up and use them incorrectly, there's a little fuse inside the multimeter that will blow, and they're probably all blown because people aren't always careful. And so it's the most likely scenario is that you're going to use this terminal when you want to measure currents. All right, it's just not as precise as it will be if we use the one on the right, but the one on the right won't read anything because the likelihood is that fuse is blown. All right, so to measure current, yeah, we want one lead in the 10A DC terminal. All right, and so that's one thing. And the second thing is you turn the dial to something about a 10 amp setting. All right, and look, there's only one. There it is. So you turn the dial, click, 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 all the way to that, and then we're configured to measure current. Okay? Now, when we're going to measure voltage, right, here's the only terminal that we can plug something into to measure voltage. So, of course, one lead always in the common terminal, but one lead in the V terminal right there. And two, we turn the dial to something, something, something DC voltage setting. So where's that? Well, look, here's some stuff about V. Here's some stuff about V. All right, look, here's some stuff about ohms. That would be if we want to measure resistance. Um, look, this is about amps. That's for current. All right, so it's either going to be in this range or this range for us measuring voltage. All right, now which one is it? Each of these, it's hard to see in our little drawing here, our little picture, but this one on the left has V with this symbol. And this one on the right has V with that symbol. All right, this little sine wave refers to AC stuff, AC circuitry. This little symbol, which I don't know what the symbol really is supposed to be, but it represents DC stuff. So that's the one we want. We want the voltage with that symbol, the solid and the dotted underneath it. Okay, we put our lead or our dial on that setting, and we put our lead in the right terminal. We've got this thing configured to measure voltage. Okay, now why all these different numbers? For example, 200 M, 220, 200, 600. Well, what that does is identifies the maximum value that will be measured or that could be measured. All right, and so what you probably want to do, what I'll recommend, and we'll only do it for this one, you know, it might go for this one too. You ought to check, if you can, you ought to try to use the more sensitive settings. So try the, when you try to measure current, try to use the milliamp terminal, all right? And try to maybe use this or this or this or this. But if they just don't read, then you're going to have to change the terminal over to the big 10 amp terminal and change the setting to that 10 amp. But you ought to try. All right, but here's what will likely happen in at least some case. If you see on your display one dot, you've maxed out the meter. And what I mean by that is it's like, let's say we had a scale, a scale for weight that could reach a maximum of 2 pounds, but you put a 4-pound block on there, right? The needle goes all the way to the right. It can't actually read that weight because it's too much for the setting we're on. So what you have to do is try another setting with a higher maximum. Make sense? All right. The lower you go, so like for example here, let me start to clean this up a little bit. For example here, this is 200 millivolts is the smallest amount. That's 1/10 of 2 volts, which is 1/10 of 20 volts, which is 1/10 of 200 volts, and so on and so on. All right, what each, you know, you'll get the same number no matter what setting you put it on. It's just a matter of how much precision you'll be given, all right, how many decimal places you'll be given, and you ought to try to be as precise as you can. All right, so look at the smallest, I mean, put it on the smallest setting you can such that you don't get this, whoops, you maxed it out. Okay? You'll know that if you see just a one dot and nothing else. Okay? Okay. Now, how do we actually connect these things in a circuit? Well, let's say we've got a battery, we've got a resistor, we've got a very simple circuit like that. All right. So first of all, to measure current, we know we use an ammeter. The symbol, schematic symbol is that. All right. To measure voltage, we know we use a voltmeter. Schematic symbol is that with a V. But here's the deal. Think about it. Ammeters measure current. They have to measure how much charge goes through something. A number of electrons per unit time. All right. And so if we want to find how much current goes through the resistor, say, here's what we have to do. We've got to take our ammeter and put it, it actually doesn't matter, before or after. Group it, group. Before or after the resistor. And what you'd actually, the better way to, draw it is like, come on, you jerk, is like that, right? So we have to place that ammeter in such a way that current doesn't have a choice. Well, maybe it'll go through the ammeter, maybe it'll go through the resistor, right? We want to know how much goes through resistor, how much current goes through the resistor. We have to let all that current that's about to go into it first go through the ammeter. Or alternatively, we could say, well, every bit of current that's gone through the resistor, let's now let it run through the ammeter and we'll measure how much that was. Okay? So that's the proper orientation of an ammeter. And if you notice, this ammeter is connected in series with the circuit element we want to measure current through. Okay, and here's the big deal for this. Typically, almost every time, replace a wire with the ammeter. So your circuit, let's say your circuit looked like this. Here's our ammeter over on the side. You have a circuit that has, we've got a battery, we've got a wire, then we clip that wire to a resistor. On the other side of the resistor, we clip that resistor to another wire, and this wire goes back to the battery. The best way to do it in my experience is say, well, this wire, see you later wire. I'm going to put you over there. I'm going to take ammeter and connect the ends of it where the wire was. Okay. So anytime you want to measure current, I highly recommend removing a wire, replacing it with an ammeter. Okay. Delete. Super. Now, to measure voltage, we use a voltmeter. And remember, the other phrase for voltage is potential difference. Potential, which you don't really have to concern yourself with too much, is energy per charge, energy per unit charge. So what we're really looking at is energy difference, right? And that means we have to compare two places. And if we want to measure, say, the potential difference across the resistor, that's kind of the proper terminology, the potential difference across the resistor, well, what you do is connect one end of the voltmeter before the resistor, one end or lead of the voltmeter after the resistor. Okay? And now we're able to measure two different levels or values of energy per unit charge and compare them to get our difference, to get our voltage. All right, so if you notice, this voltmeter is connected in parallel with the circuit element we want to find the potential difference across. Okay? And the easy thing about voltmeters is there's no replace something with something else. You literally just like hold onto a wire and just go poke, and the other wire and go poke, and just see what the thing says. So you don't have to disconnect anything like you do for ammeters. Ammeters can be trickier to use. Voltmeters pretty straightforward. So when I say parallel, I mean, you know, kind of before and after. All right, now the other thing about these is look at how these things are connected. We've got this ammeter that we're putting all the current through before it goes through the resistor, or you know, any current that's going through the resistor now goes through our ammeter. We've got our voltmeter connected in such a way that, you know, here's a what we call a junction, and current, you know, that gets to one of those junctions could actually split and could go through the resistor or the voltmeter. But when we use these meters, we don't want to alter the way that, you know, the original circuit operates. There's the original circuit. By measuring, we don't want to change the way it typically behaves. And so we put an ammeter in here. We want to make sure we don't slow down the current. All right, because we want to know how much current goes through this when it's set up like that. Well, here's what we can't do. Add more resistance in there. So what we have to do for ammeters is give them really small resistance. Really, really small resistance. Current just screams right through them. No problem at all. However, for the voltmeter, look, let's say that some current gets to this junction. Well, you know, typically a certain amount of current goes through that resistor. What we don't want is to take some of that current and let it go this way. And so to keep current from going through that voltmeter, we have to give, or voltmeters are given, very, very big resistance. So it's a little bit of trivia, but it does have a, you know, a basis in understanding why, you know, what measurements we're making and why we, or how we, you know, how we make those measurements without changing the stuff we're trying to measure, or without changing the system we're trying to observe. That's better. Okay? The super duper important parts: voltmeters, parallel; ammeters, series. Super important. Okay? And I like this a bunch too. Good, good? Good. Now I'm gonna draw a couple of circuits here. Each of them will have two different circuit elements, a resistor and a light bulb. All right. In that case, they're connected in series. In this case, I'm going to connect them in parallel. All right, but in each case, here's what I want to do. I want to measure the current through the bulb, but the potential difference voltage across the resistor. All right, well, current through the bulb. Here's what I'll do, right? Remove wire. Replace with ammeter. Notice that ammeter is in series with that bulb. Check. Potential difference across the resistor. Well, that's voltage across the resistor. So we look before and after the resistor, but only the resistor. There's our parallel voltmeter connection. Okay? We do that over here. Now, yeah, okay. So we do that over here. Let's see, current through the bulb. Again, let's replace a wire with, well, let me do it in blue like I did before. We yank out that wire, replace it with ammeter. Now notice up here I put it before the lamp. Here I'm putting it after. Doesn't matter. And now the voltage across the resistor, well, we connect in parallel before and after that resistor. All right, what I'm trying to show you here is that these two circuit elements, the resistor and the lamp, are connected in series. But that doesn't have anything to do with how we connect the meters, right? Ammeter connected in series with bulb. Voltmeter connected in parallel with resistor. The fact that the resistor and the bulb are connected in series, who cares? Right? On the right, we have resistor and bulb connected in parallel, but we still have an ammeter connected in series with the bulb. We still have a voltmeter connected in parallel with the resistor. How the resistor and the bulb are connected, who cares? Just make sure that your meters are connected in the way you want them to be connected, with the element that you want them to be connected with. Now notice, if we had replaced this wire here with an ammeter, that would measure the current in the whole circuit. The fact that we go from this junction to this junction, well, this branch is where where the bulb is, so our ammeter has to go in that branch. It can't go before that junction or after that junction or those branches come back together. Does that make sense? So the placement of those, super important. Okay, I think that's it, folks. That's a little precursor on multimeter use. I'll expect that you'll be reasonably comfortable with the ideas we talked about here when you get in to the lab next time I see you. Of course, I won't expect you to be pros, but I'll expect you to be able to speak the right language about how these things are used and how to set them up to do what you want them to do. Okay? Okay. Happy day.